This will be part 2 in the series on natural selection, and we'll use the stick insects to look at some of the finer points of the process. This species lives in Malaysia. First topic, we'll take a look at variation. Now, reproduction produces variation, which is necessary for selection to occur. The variations are the differences that might make a difference to survival. Without variation, there can be no selection process. Nobody would have a relative advantage. It's important to note that reproduction produces random variation. Neither the parents nor the environment have control over the process that produces this variation. And what would that really mean? Well, consider the story of the stick insects. So the ancestral population enters into a region with sticks. The idea here of randomness is that just because there's sticks here, the new environment does not cause useful variations. Right? So the environment with sticks does not cause certain mutations to make offspring more stick-like. There's no way that the stick-like environment can get down into the DNA and influence the production of sex cells so the next generation looks more like a stick. We now know, of course, that mutations arise when during DNA duplication there can be errors that happen. The protein machinery sort of makes a mistake when copying DNA. And these DNA copy errors or mutations are random in the sense that there's no way for the cell's DNA duplication machinery to know which error would make a more stick-like body. So the stick environment can't influence this process, neither can the parents. The parents are looking around saying, hey, we're in a bunch of sticks here, let's have more stick-like babies. They can't influence this process either. So the variation is random with respect to the sort of characteristics of the environment and what would be a good trait or a bad trait. So the take-home point here is that variation is generated by biological processes without regard to the needs of the species in a certain environment. Some individuals are just going to have good mutations or a good mixing of parental genes, and others less so. Now, while variation is random, natural selection is a non-random process. Remember, the predators here are not just randomly eating their prey. They're eating the ones that they see. So there's going to be an unequal chance of survival because of the variation in body shape. So this is a non-random selection process. If it were a random selection process, the predators would sometimes eat the thinner bodies and just as often eat the thicker bodied ones. But that's not how it happens. There is an unequal chance of survival. So as the most stick-like body shape each generation is non-randomly selected, the trait becomes more frequent in the population and can even improve. So again, with the variation and a non-random selection process, you get the evolution of the population towards greater and greater fitness to its local environment. In this case, stick-like bodies that are good camouflage to avoid predators. So there's no goal or end state to evolutionary change as there is when humans purposely select traits in domesticated plants and animals. Rather, the result of natural selection is simply better adapted species to their local environments. And so, natural selection is a natural cause and effect process that produces well-camouflaged insects, but there's no intelligence, in a sense, driving this process. Natural selection produces the appearance of design without an intelligent mind.